You might have already noticed that almost every single disc golf disc comes off our injection machine with this weird little guy attached to the bottom of it. Technically, it's called a sprue. And honestly, until we started making discs, I didn't realize how interesting / important these things actually are. So what is it and why does it even exist? To answer that question, we need to talk about cold sprue bushings, hot tips, and valve gates. And you'll just have to trust me. I know those sound like the most boring things side by side, but they truly are fascinating. So we really need to start with how a disc is made. Actually, we need to talk about something else. Before a quick primer on how a disc is made, I actually think we need to talk about why now. Like, why are we talking about the sprue at this point? And the reason is because our new driver, the Procyon, has a different type of system than anything else we have. So the Canyon and Inner Core have one thing, the Ozone and the Dune have something else, and the Procyon has something completely new to us. So to set the context for all of that, we kind of need this video. All right, back to it. So we really need to start with how a disc is made, but we've made entire videos about that. So this is gonna be the speed round 30-second overview. Basically, there are three components. There's the plastic, the injection machine, and the mold. For us, the plastic is 100% recycled plastic. Mostly we use a plastic called TPU, which stands for thermoplastic polyurethane. Then you have an injection machine. On one side, you have the injection unit, which deals with melting and injecting the plastic. And on the other side, you have the clamping unit, which deals with opening and closing the mold, which leads to our third part, which is this big hunk of metal called a mold. Inside of said mold, there is a cavity, basically an open space where plastic injects into, fills out, and when you open it up and get it out, you have yourself a disc. For what I want to talk about today, we need to actually zoom in really close to two parts of the machine and the mold. On the machine, there's a big barrel, and at the very front of the barrel, there's a thing called a nozzle. Actually, this is what that nozzle looks like. So this part screws into the rest of the barrel, and then this is the part that actually is where the plastic injects out of and into the mold. So naturally, that also means this butts up right against the mold. And in most injection molding applications, that's gonna be with a thing called a sprue bushing. Please forgive the dirty mold, but this is a piece of the mold, and this is exactly where that nozzle would run up against. That piece is what's called a cold sprue bushing, and it kind of looks like this. All it is this, hollow channel running through this piece of metal. So basically you have the nozzle, and the nozzle meets up to the cold sprue bushing, which then allows you to inject into the mold. So another way to say all this would be to say plastic still has to travel from here into the mold to be able to access the point where the disc itself is going to be made. Which means you're injecting plastic through this hollow channel, and then once the disc cools inside the mold, what also cools with it is the plastic that's inside this hollow channel. So when a disc comes out of the cold sprue bushing, what do you have? A sprue attached to the end. So I'm sure there's actually an official definition for like what a cold sprue bushing is, but my definition is that it's basically just a hollow channel that allows plastic to flow from the machine into the cavity of the mold. It's also worth noting that a cold sprue bushing is cold. It's not hot. That might sound like the dumbest thing ever, but it applies to something we're gonna talk about in a second, so trust me there. So we know what a cold sprue bushing is now, which also tells us why discs come out with a sprue attached to them. But we've gotten this comment a couple times, and some of you are paying attention quite closely. Why do some of our discs not have a sprue attached to them when they come off the machine? Specifically, the Inner Core and the Canyon have a sprue attached to them when they come off the machine, but the Ozone, the Dune, and our new Procyon do not, which is where we get into hot tips and valve gates. So this is a hot tip, and it kind of looks crazy. There's a lot happening here, and it looks crazier than it actually is. Basically, a hot tip, if you're looking closely, is a heated cold sprue bushing. So with a cold sprue, you have this cold channel, and with a hot tip, you actually have a heated contraption surrounding that channel, so the plastic is actually hot all the way from the machine through the hot tip and into the cavity of the mold, or in our case, the disc itself. Because it's basically just a heated channel all the way to the disc, when the disc has cooled in the mold and you open it up and take it off, this part doesn't come out with it, leaving it sprueless. That can't be the right word. The big question here is, why would we use a hot tip instead of a cold sprue bushing? And we will get to that in a moment, but there is one more type of contraption you can use, which is called a valve gate. In our case, the hot tip is on the Procyon mold, and the valve gate is on the ozone and the dune mold. Now, a valve gate looks way more complex than either a hot tip or a cold sprue bushing, but really you can zoom out and it's not too complex either. Basically, if a hot tip is the same thing as a cold sprue bushing but heated, a valve gate is the same thing as a hot tip, except it has a little valve inside that opens and closes. It's also worth noting that the hot tip and the valve gate kind of both exist under the umbrella of like a hot runner. So for our purposes, there's basically two main categories. There's the cold sprue category and the hot runner category. I'm just now realizing we need to go back to the top because there's one thing I forgot to talk about, which is, okay, there's the hot runner systems, the hot tip and the valve gate, and then there's a cold sprue. There's actually one more cold runner system, and that's actually not making a cold sprue and just having a hole through the mold itself. So there's some discs where you can see a little nub on the bottom that has a little circle around it, and then there's other discs that have a nub with no circle around it. Basically, the circle is just a witness mark of a cold sprue bushing, and the no circle around it basically just means they had a pass-through channel milled into the mold itself. By the way, it's worth noting that we're talking about most of the discs out there that are just injected straight into the bottom center of the disc. There would be a couple caveats here, like rubber discs, which are actually compression molded, or even over-molded discs, which, fascinating note there, I'll talk about later. So in disc golf manufacturing, why would we choose cold versus hot? Or in our case, why do we have some of each? This is where there are a lot of answers to the question, and I will definitely not be able to cover them because sometimes it comes down to like what the company had on hand when they were making the mold. But there are a few primary reasons that I want to talk about, and in our case, we've seen pros and cons on both sides. So what I want to do for this video is evaluate them according to the HSMCPC evaluation criteria, which you're probably wondering, what is that? And Jesse, did you make that up? And of course I made it up. Based on what we've seen up to this point, these are basically the 5 different pros and cons as to why you would choose cold versus hot. And the first one is heat, specifically the transfer of heat. Interestingly enough, you have your nozzle, you have your cold sprue. The nozzle itself has a band heater on it, and it's north of 400 degrees. Whereas the cold sprue, being part of the mold and cooled by the water channels in the mold, is likely 110 degrees or less, meaning something really hot is touching something really cold. At this point, according to what we've seen, it seems that it's easier by way of processing and ejecting the disc from the mold and all kinds of different things when the nozzle itself is hot and the channel is hot as well. So when you use a cold sprue bushing with a hot nozzle, it actually can create some complications. So according to the aforementioned evaluation criteria, I would say that cold sprue bushing actually ranks lower than hot runner systems when it comes to heat transfer. So that's the H of the HSMCPC criteria. Next up, we have the S, which stands for suction. TPU, aka thermoplastic polyurethane, aka premium plastic in disc golf discs, is like a suction cup. It's such a crazy, like sticky material that, no joke, right after a disc is made, when it's sitting on the table flat, if you try to pick it up from the sprue, you literally can't. You'll actually probably pick up the table before you pick up the disc. Kyle's just not strong enough to show you that part. So why does the suction matter though when it relates to this guy? Well, because TPU is so sticky, if you split the disc down the middle, you have like the bottom half of the disc and the top half of the disc, right? When you're making a disc, this is the core, so like the bottom part of the disc, the TPU just wants to suction super tight to this piece, which is actually why that piece is split in two with the core and the stripper plate. The stripper plate is literally called that because it helps strip the disc out of the mold. What we've found is that the sprue actually makes that suction even a little bit worse. in that there's just more area that's trying to hold tightly, as opposed to when you don't have a sprue. So bottom line, hot tips and valve gates are actually a little bit better with suction than a cold sprue. So far, you're probably thinking to yourself, it's obvious you should go with a hot runner system because this cold sprue just looks like it's not doing any favors. But that's where we get into maintenance. When it comes to a cold sprue, the maintenance on this guy is nothing. It's literally just a cold channel, and you can actually even access it when it's on the machine itself. So if you have any problems, you can address said problems. But we haven't had any problems other than the plastic will occasionally just stick inside of here. So the disc comes out and you have a sprue just stuck inside. And there's actually a tool for that. This is not a corkscrew, even though it looks like it. This is literally called a brass sprue puller. The things I have bought for this company that I never thought I would buy in my lifetime. So pretty much the only maintenance you could have to do with one of these is either replace it, of course, or if you get plastic stuck inside, you just heat this guy up, you stick it in there, it cools off inside with plastic around it, and then you can pull the sprue out. So maintenance is easy with a cold sprue, but not so with a hot runner. If you need to do maintenance on a hot runner, you actually have to take the entire mold out of the machine, open the mold up in its entirety, and take the hot runner system out to then diagnose what's going on. And valve gates are actually even worse than hot tips because the contraption is made up of so many more components that sometimes you have to take apart the entire thing to figure out what's going wrong. And that actually happened to us recently with the ozone mold, and we made a Patreon video about how we had to take apart literally every piece all the way down, try to figure out what was going on, put it back together, hope that we put it back together right, and we could start making ozones again. Luckily, that one worked out. But if I never have to take a valve gate apart again, I'll be happy. So that's the maintenance part of the HSMCPC criteria, which means the next is the cost. And you're an expert at this point, so I'm sure you could guess. Basically, a cold sprue is definitely gonna be the cheapest. Then a hot tip is gonna be more expensive, and a valve gate is gonna be even more expensive. It's also worth noting that that's the upfront cost, but when you include labor in terms of diagnosing and fixing problems, so back to maintenance. And then when you include parts and service, the mold design itself, because now the mold is going to be designed differently, and then ancillary equipment on top of all of that, because for hot tips and valve gates, you need a thing called a hot runner system. Basically, when you include all of that, the costs increase pretty dramatically. If I had to guess, I would think that maintenance and cost are gonna be the two main reasons people typically go with cold sprue over hot runner. But all four of those things really are the top 4 pros and cons that we've seen for why using hot versus cold systems. However, there is a 5th category, and I guess it does apply to everyone else, but this one has a very unique application specifically to us, which is why I call it the phone case criteria. Technically, certain plastics prefer cold sprues versus hot tips. And being that TPU is super sticky, it especially has a hard time with a valve gate where you need a piece to actuate back and forth, all while being intertwined with this sticky material. Hypothetically, the plastic being melted should make it just fine, but it really depends on the viscosity of the plastic, and TPU is just, honestly, it's kind of like glue. But beyond that, let's say you hypothetically recycle phone cases. And let's say that hypothetically those phone cases have 2 slightly different plastics in them where one homogenizes while the other creates this really nice flake effect. If you imagine that plastic being melted and flowing through just an open channel, it should be just fine, right? But what if you put it through the valve gate? What if you introduce that material and those flakes in a place where it needs to open and close? Well, we did that. We tried phone cases in the ozone. And after that, we're not sure if it's the exact reason, but after that, the ozone mold broke. And that's why we needed to take apart the entire valve gate and fix it. So I guess what I'm trying to say is that's why the phone case inner core is a thing, because it has a cold sprue bushing. And that's why now, as of today, the phone case canyon is a thing. They're made from a special batch of these glittery phone cases that we got in. And I just have to brag for a moment on the team and say, these have to be the prettiest discs we've ever made. So when all is said and done, with all of the pros and cons, as we continue to build more molds, I think I'd choose the cold sprue. The valve gate and the hot tip have some really cool aspects to them. But when it comes to maintenance, when it comes to cost, not just like the startup cost, but the ongoing cost, and when it comes to phone cases, maybe mostly when it comes to phone cases, I think the cold sprue fits our needs perfectly. So that is the wonderful world of cold sprue bushings, hot tips, valve gates, you name it. I never would have thought that something so small would have such an interesting, convoluted, and funky story, but the more you know. Also, special shout out to the Magenta Sparkle Phone Case Canyon. This thing is insane in person. Okay, you're in the deep end now, which means I promised a little thing about overmolded discs, and this is it. So technically you can use a typical cold sprue bushing or even just a hollow channel through the mold itself for like the flight plate of the disc itself. But how do you get the plastic to inject around the disc and in from the rim? Well, this is where you actually have to use a hot runner system. Let me show you. So this is the Smarter Everyday MVP video, and right here is the nozzle. And this would be where you would typically have some kind of sprue bushing that injects straight into the disc. But as you can see, you actually have a channel that goes down, around, and then injects from the rim itself on both sides. I think he actually shows it injecting here. And yep, there you go. Boom. So what you cannot have is all this blue plastic harden in there and just be stuck, right? If it just hardened inside the mold, it would just get stuck, and then you literally wouldn't even be able to inject the next shot. So that is why, technically, in some scenarios in injection molding and in disc manufacturing, you don't even have the choice between different types of systems, and you have to use one. Maybe I'm just a nerd, but I think that's pretty interesting. Okay, so I just finished editing the video, and there is something I forgot that I cannot believe I forgot. But basically, we need to add a criteria to the HSMCBC criteria. And this is kind of embarrassing, but the recycling guy forgot waste. We need to talk about waste. Technically, when I was first introduced to a valve gate, it was because of the idea that it would create no waste. So valve gate and hot tip, both of those are great when it comes to creating waste in that they don't create waste. Whereas a cold sprue creates that little sprue every single disc. And after hundreds of thousands of discs, it really starts to add up. To be fair, I always forget about it because our waste will never see a landfill. Like, that's something we're deeply committed to. So every sprue, the flashing we trim, the discs that come off the machine that are manufacturing defects, like no matter what, all of that will be recycled. And since we're running a grinder already, it really is only a small additional amount of energy that's being used. But regardless, it's something that needs to be noted because it's a thing. And there are even some shops that don't even have grinders or do anything like that. So I guess when all is said and done, it's technically another check mark on the hot runner category and another X on the cold sprue. Please keep this between us because the guy who really deeply cares about sustainably forgetting about waste in the whole criteria is a little bit embarrassing, but whatever. It is what it is.